We already talked about forming bonds between atoms, and now we're going to talk about how can we break bonds between atoms. In this simulation, we have a molecule here. Right now, it is made up of two hydrogen atoms that are bonded together, and we also have a third atom within the system. We're going to pay close attention to the behavior of those atoms, how they act, meaning their movement specifically, and whether or not that bond breaks or not. Along with, we're going to be keeping track of their energies. Specifically, remember, we care about their potential energy and their kinetic energy. I will say that when we look at breaking bonds, we are going to be looking pretty closely at the amount of kinetic energy. So, in the simulation, things that I can change the velocity of this third atom here. The first time I do this, I'm going to keep it relatively slow. And we're just going to observe the behavior of these atoms. So let me hit play here. And pow! Perfect. I'm going to hit pause. So we saw that the velocity of that third atom was relatively slow. It came in and then it collided with that molecule. Now, the third atom, you should have seen that it slowed down a little bit after that collision, and that this molecule here actually gained some speed, right? It started moving after that collision. If we take a look at the graph here, what we notice is the dark purple line representing the third atom there, the blue one. It had high kinetic energy because it was moving. Then it collided with the molecule and that kinetic energy dropped. The kinetic energy of the molecule is represented by the light purple line. Notice that the light purple line was low because it was relatively stationary, and then it collided, and all of a sudden its kinetic energy spiked. It increased. When we see that there's like a flip-flop here, right? The kinetic energy of the third molecule drops, the kinetic energy of the not the third molecule, but the third atom drops, and then the molecule itself jumps, there's a transfer of kinetic energy happening between those two. Now I want to reset this and I want to increase my velocity enough that we can start talking about how can we actually break bonds, right? Because that, and in that scenario, we didn't actually break the bond between those hydrogen atoms. It was still there. It was just a rocky relationship. But let's try and actually break that bond. So I'm going to increase the velocity somewhere midpoint. And let's take a look at that. So I'm going to hit play. Much faster, so much higher kinetic energy. Again, there's a transfer of kinetic energy to that molecule. And we see that in the graph by the drop in the kinetic energy of the atom versus the increase or the spike in kinetic energy of the molecule. Now, specifically though, why does that bond break? Well, remember when we talked about forming bonds, two atoms by themselves can't form a bond because they end up having too much kinetic energy and they can't hold on to themselves. Well, now we've just transferred kinetic energy to a molecule that was already stable. Well, now the amount of kinetic energy that's been transferred is too high. In fact, there's so much kinetic energy that it outweighs the attractive forces that are holding that bond together. And so that bond will break.